I guess we can start. But before we start, any questions so far? Any question that you want to raise? Any question that you want to discuss before we? Uh, Today we'll finish Anova, but we will combine the quiz with regression because of the time constraint. So we will combine the two quiz together. But that will be the only announcement I want to make as of now. Any question before we start? If no, then we are going to work it out. Okay. So Anova. So what is exactly Anova is again is can you see my you can't see my slides, right? I guess. Upload the answer of homework. I think I can give the I can give you the final answer, but I don't think I can give you the detailed answer because of the restriction from the publisher that that don't allow me to give you the full answer. Yeah, I can give you the short answer. Or I think it's easiest. I can give you answer. So answer, if you have a question, you can ask the TA for personal explanation for the. That would be easier. Donald, is it okay? Yeah, I guess the TA can give you more detailed explanation, but for the uploaded, I won't upload it because of the restriction that imposed on me by the publisher of the textbook. I cannot give a detailed answer for that, but I try to give you the short answer for those. Okay, I hope that would be fine. Yes. Any more questions? Let me write down to do the short answers. Okay. If there's no further question, then we start. Let me know if you have no further questions. Just remind you, we finished the Anova, but both the homework and the site and the quiz will be combined with the regression because of the time constraint we have at the moment. Because I think we lost one class due to the National Day, so that's why. Anyway, so you don't have to find a group, you can just find yourself. You don't have to group up. It's an individual or group. You don't have to group project. Someone asked me whether you can find a group, you don't have to group. If you want to, you can actually, I actually, this at the project actually better to do it individually, but because some of you would like to learn how to keep up with others, then you do a group, but otherwise you can just do individual. You can just continue what you do for homework one and expand it. That would be your project. With the group, because we said group, we were expecting there will be in class, then you can talk, but now we don't. But we still allow you to do group. But is that okay, Kelly? Yeah, but you can do individual. I mean, because you can see the group and individual are proportional, so there's no gain or loss to do individual group. By group, you want to group because you want to do a bigger project, then you do a group, right? You need a date. Sorry, it should be December 11, I guess. I changed it already, no? So December 11th, or maybe the announcement, right? I guess. Yeah, you can choose the I think as long as there's enough time, I think it's not matter. But you have a big group that have different people from different group, then I think you have to figure out how you have to follow the majority. Okay, so if you have 2 people from one group, the other people from the other group, then you should follow the majority. Yeah, I think that would be just allow you to choose, and then at the end, it will be because time constraint for 2 class, and we have to make some lottery. Otherwise, it would be allow you to choose, but subject to lottery. I hope that's okay. Any further question? Yeah, feel free to ask because of this, the time now is we are meeting online. The communication can be an issue. Any further question? If no, then let's get started. I hope you can see my slides. Is it? So analyze a variant is Anova. Okay. And before we had t-test, remember 2 sample t-test is testing whether mu1 is equal to mu2, right? Here we have more. Anova is asking Anova is asking the following: mu1 equal to mu2 equal to mu3 equal to mu4, and so on and so forth. It's more mu's. Okay, so that means that we require some more different technique. Actually, we'll use f-test, okay, to do it. Okay, so that's the idea. Okay, so that's why we need more notation to make it work. So one way Anova, okay. Just to recap a little bit what we cover. Okay, the data you have is a data grouping. So we say variable and factor is grouping. Okay, and the data point, each data point will be telling you that what the data number is and the grouping. Okay, you can imagine that before 2 group, maybe male or female, right? Maybe the grouping is male or female, that's 2 group. Now we consider maybe 3 group, maybe location in Hong Kong, right? Maybe it's Hong Kong Island, Kowloon Peninsula, or New Territory, right? So that would be the 3 grouping, right? The variable you focus on maybe say time to CUHK, say, okay? How much time you can spend, right? You need to come to school, okay? And there's a data you collected, right? And sometimes you may see people write in this way, okay? Instead of writing a pair, you use the notation called Xij, okay? And I is which group, and J is the observations. Okay, I've group, J observations. Is that okay? And usually what you have, you can see is you can group them in the spreadsheet, group 1 up to group N, okay? And this is the observation from 1 up to N1, right? And do note that here we don't restrict N1 equal to N2 equal to NC here. We don't have this assumption where we have this such assumption to about two-way ANOVA. And is this assumption necessary? No, but for the sake of discussion, we will assume everything is at the same number, okay? And again, you can imagine this is a drug number 1, drug number 2, drug number 3. You want to see whether the drug has the same impact or not, okay? So that would be the idea. Is that okay? Any question? If no, then we go into the model, okay? So the model here is, sorry, square here. The classical linear model would be saying that each observation have a normal distribution, okay, with its mean being mu I. So each group has its own mean, okay, and they have the same variance, sigma square, okay, and if you write this, is equivalent to you write this way, okay. You separate observation by its mean, which is a constant, a non-constant, but it's a constant, okay? And this part is a random variable with 0 mean, okay? Same variance. Okay, this is the standard way you write things, okay? This is the standard way people represent model in this way, okay? Later you will see this is very common way people think. Separate the constant term and the random term, okay? And here we have another idea, because we care about whether the mu1 is equal to mu2 or not, the question, right? So that's why it's good to say mu is, again, separate two parts. One is a constant, and the other part is can be positive or negative. It's called Truman effect, okay? And what we want is to see if this Truman effect equal to 0 or not. So the question is, okay, so it's trying to check whether Truman effect, because it's usually you use the drug and you see whether different drug have different effect or have any impact, right? So that's the idea. Okay, I hope that is clear. And what we have next, again, as I said, either they have same mean, which group, or they have the same 0 treatment effect at all. So the drug or marketing, and then what we do, remember F-test, right? If there's only compare mu1 and mu2, then we can just do T, right? But if you have more, then you have to do F. So that's the idea. So the next part would be just bunch of definitions, just bunch of equations, and those formula will tell you F-test. We'll try to explain why this F-test, okay? So just definition. So okay, so the data you have is group 1, group 2, group 3, up to group C, right? Maybe just, we don't need this one, group C, right? And data here, X11, X12, up to X1N1. Similarly, you have X21, X22, and this may be longer, right? Maybe X2N2, maybe the same, okay? And at the end, with XC1, XC2, resultant, XC and C, okay? So first grand mean, the grand mean is overall mean. You will just, if you think about Excel, will be just summing all the data divided by n, so it's average, right? Average all the data, right? So here the notation is you summing all the group from I1 to C, just go in this direction. I is 1 to C, right? Just each observation I, right? Each group I from 1 to C, and from each group I, you are summing from the first observation to the last observation. So it just for each group, you go to this direction. Okay, for each group 1, add up all this, group 2, add all this, add up all every observation divided by n. So this is what it means here. Okay, you can say it's sum of all observations. Okay, over n. Okay, and the next one will be rather simple, right? Just look at group I, okay? You actually add them all the observation, okay, from the first to the last. So for group 2, you're going from the first observation to the last, right? So this is, if you look at the Excel, this is the average of a column. Okay, if you use Excel, the idea this is average of all cells. Is that okay? Any question? No? Okay, good. So that is the idea. And let us see it again, okay? The SST, okay, will be just looking at each observation minus the mean and take square, okay? And you do it from every group 1 to group C and for each observation in each group, okay? So basically, for every observation, you minus the mean and square, add them up, okay? And the between group, okay, we'll be looking at the observation of each group minus the bar overall mean. So basically just replace each observation by the mean of the group. Okay, so basically if you look at the data you have is like this, right? So what you have is group 1, group 2, group 3, okay? So there will be X11, X12, and there will be X1 and 1. Sorry. And calculate the average of this column gives you X bar 1. So what you're doing here is you don't use this as observation, you replace it with X bar, okay, X bar 1. And you do the same procedure again, okay? By doing so, basically each group has no variation. Okay, so that's why it's between group, because each group, you just focus on X bar, okay? So that is how you calculate this object. Okay, don't worry, it will be calculated by Excel directly, so you don't need to worry about the formula, but you just need to know what are they. Okay, the SSW is, instead of replacing this, okay, you are subtracting not the overall mean but the group mean. Okay, you're looking at each group, how the individual difference among the group. Okay, and which you will show in the next topic in the regression, which shows SST, which is the overall, is equal to this two. Okay, SST is equal to SSG plus SSW. So that is the idea. Okay, and now I think we are ready to discuss the following. So this is MST, MSG, and MSW. MSG is nothing but just standard sample, just standard sample variance, right? Because there are n observations, right? So sample variance is n minus 1. Okay. And so now the next is, this is SSG, and you may ask why this is equal to C minus 1 here. We are not going to explain. Actually, we will the proof. Okay, there's C minus 1, and this is n minus C here. Okay. One of the reasons you can imagine that this is only this n doesn't really matter, right? So basically, just there are only C object here, x bar 1 up to x bar C. There's C random variable here, right? And you calculate the variance of them. That's why it's C minus 1. Okay, so that is the one idea that why C minus 1. Okay, and why did n minus C here? The intuitive explanation is we only have used one sample variance, so this minus 1. So here we use x bar 1 up to x bar C, so that's why n minus C. Okay, of course, this is kind of coincidence. It's kind of related, but we are not able to explain without going to proof. The proof, you will see why we need this, but for the moment, that is sometimes people call, also Excel called degree of freedom. DF, degree of freedom. This is degree of freedom for MST. SST is n minus 1, C minus 1, n minus C. Okay, and so here is the F test. So the F test here is trying to see if the mean are different. Okay, and the way to do is compare the MSG and MSW. Okay, MSW, and the degree of freedom is C minus 1, n minus C here. Okay, so that would be the goal. Okay. So we are trying to give you idea of the proof for this. Okay, but for some step of the proof, we require something we didn't prove. Okay. The reason why we skip the proof is because it's beyond the scope. It requires some more complicated method than we need. Okay, so that's that we will just claim. Okay, so the proof, first, Anova would say that would be the case, right? Because this is somewhat we have said. Okay, and for each group I, okay, the variance, you look at the observation minus the sample mean over ni minus 1, right? That would be the standard idea of sample variance. Okay, and here we rely on the thing we didn't prove, but we claim it and we use it all the way anyway. Actually, we use it all the result before we have, right? Is trying to say ni times si is basically just this guy, right? Basically the summation, right? The summation over the sigma is chi-square derivative ni minus 1. Okay, so basically this guy has degree of freedom ni minus 1. And look at what is SSW. SSW over sigma square will be this guy, okay, which is simply this guy, right? Because check it here, this is here, and this is here. What here is you add up each group from 1 up to C. Okay, from 1 up to C here. To see here, so that would be the difference. Okay, that will be the sum. Why? Because this is group 1. Say the group 1 will give you this n1 minus c, n1 minus 1, right? You add up n2 minus 1, square nc minus 1. You add up with the same, this one, right? Because n1 plus n2 plus nc minus c here, this is n, so this is n minus c. So that is the reason why you have this as SSW. Okay, and the next part here is the denominator would prove SSW, MSW, but now we need the numerator. Okay, how to prove SSG? Okay, between group. The idea is again very similar, but we also without a claim because we didn't prove. So under the null, okay, the group mean all the same. So mu1 equal to mu2, right? So that's why the sample mean will be equal same mean, right? Like this. And now you can rewrite this normalize in this way. I hope this is somewhat you know by now because this is standard normalization. Okay. And for this, you can also this is a random variable, right? You can calculate the I of the C of them. You can calculate sample variance. Right? There's nothing new here. Okay. Because this is minus 0 divided, right? It's a minus, should be this minus 0 and divided by 1. So that's why sample variance. Okay. And just use the claim we have, was similar to the claim, actually didn't prove it. We'll be saying this guy or this guy is chi-square derivative c minus 1. So this is the part we don't prove. Okay, this is the part that beyond our scope. Okay, but what it said is this SSG over sigma square will be this guy actually is chi-square c minus 1. Okay, so that's why you can immediately see this is MSG, right? This MSW, okay, and then you divide and multiply the denominator by sigma, okay, all right, and this is the chi-square, okay, the ratio of chi-square is f, okay, so that gives you the degree of freedom, and you can actually do the t-test, right? You know how to do it, and we know how to do it. That's not a big issue here. Now, before the break, I want to give you the idea how we can do it in the Excel. Let me do in Excel. Can you see my Excel spreadsheet? I hope that's clear. So the data we have again, we have a one-way ANOVA that would be, say, as I said, with Hong Kong, Kowloon, and New Territories. Okay, the data maybe I just make up some data. Maybe the time you need to go to school, right? So how many minutes if you take public transport to school? Okay, if you're in Kowloon, maybe you take half an hour. I don't know. You live New Territory, maybe depends on where you live. Can be much more variation. If you live in Yunnan, can be very long. Okay, something like that. Okay. So now what you want to see is this is the travel time to CHK, right, to our school, okay, for a student, okay, of different occasion. So you want to do ANOVA. How do you proceed? Go to what you do. We'll go to data analytics. That will be the furthest way. We're very fast. Okay. So go to data and data analysis. Okay. Make sure you add in of data analysis. Okay. Analysis toolpad have installed it. I hope you have done it. Okay. So data analysis. Okay. Go to the very first one. We're using the Anova single factor. Is it okay? Anyone who can follow? You can put in your data. You don't have to follow my one for your fun. Is that okay? Good. So click on this. Then you have several things. There's input and output option. Input range. You just highlight, click and highlight everything in your data. Here I have A1 up to C7. Depends on the length. You just highlight everything in your data. Okay, you click on the data. And the data here now I have grouped it in the column because data appear in the column. Of course, you can enroll, but the most convenient one way is a column form, as we have shown in the slides. And label in the first row, yes, because label in the first row, right? So it's you take table circle. Alpha, as we have said, usually we have a 95% confidence level. So that's put 5% by default. Is that okay up to now? So just to be sure, you input data range, okay? Tell them your column or your range, sorry, or row, okay? Do you have label? Okay, and then you choose the output range, and then you're done. Output either you have new workbook, new worksheet. Usually I put it on the side. So see, I put E1 say. Put E1 say. Is that okay? What we are doing now here? If no question, I just put OK. Okay. Now let me make the screen smaller because that will show everything here. Okay. So here is Anova single factor. So here we have the yellow. Let me yellow out. The blue out. Blue, make it blue. So for blue region, it's the summary statistics, right? So count, you have 5 number Hong Kong, 4 Kowloon, and 6 New Territories here. Sum will be just summing all these columns, right? For Kowloon, Hong Kong, Kowloon, New Territory. There's all the sums, okay? And average will be just average of all this data, okay? And variance by default is, I think, sample variance, I guess. Let me check. So this is to be sample variance. Yes, this is sample variance. Okay. And all these are summary statistics. Okay. And now the part now, I think the most important is the yellow part. I think that would be the key here. Okay. And so between group, within group, I think the same notation as in using the book, but sorry, in the slide. Okay. So I think this is SSG in the notation. This is SSW. Okay. And how do we do this? Remember how we do this, right? It is SST, right? How we do this number, right? It will be the, you take 60 minus the mean, overall mean, right? Overall average, and then you do all the thing in square, right? Same, you will do similar for SSG and SSW, right? And DF is 2 because you only have 3 groups, right? This is C minus 1, right? And this is within group, this is N minus C. Okay, this is N minus 1. Okay, remember N is 15. Okay, and C is 3. Okay, and MSG will be SSG over C minus 1, right? So this dy this equal to this, right? This dy this equal to this. Is that okay? So this is MSG and this is MSW. Is that okay? And F would be given by the MSG over MSW. Okay. And this would, you can do the p-value method or the critical value method, right? So remember F will have a distribution of C minus 1 and minus C, right? Cn. So it's F to 12, right? And look at critical value. Okay. Here we get 0.039. So that is less than 5%, right? So we reject the null that they are the same. Okay. Is there any question? If there's no question, then let's have a break because now it's 11:15. So let's have a break until 15 minutes break. Will be 11. We will meet at 11:30. It's a break of 15 minutes. F. Someone asked me, was F critical? It's critical value. Looking at the right side, look at the critical value. It's a one. Is it one tail or two tail? I think this is the right tail one. Let's check, right? Because I think that would be, if you ask this question, it's easiest to check, right? Because what we have is F inverse right tail. 0.5% degree of freedom, 12, 2 and 12. Yes, one-sided. It's one tail. So it's one tail. It's a right tail. It's a right tail test. There's a question whether the homework tool, can you handwrite? So yes, you can handwrite and scan. Yeah. Yeah, handwrite and scan is good. No problem. I don't think I have to say making handwriting. Yeah. And so I guess before we go, the test cover everything in the class. So someone asked, what's the coverage? Everything in the class. Probably just have to remind you, someone asked actually during the break, is the critical value, probably I should show the Excel spreadsheet, right? The critical value here is the right tail. So for this Anova is the right tail test. So you put 5% on the end. Okay, just following the textbook, you reject on one side only. So it's a one-tailed F test. There's a rejection on the right. So we don't explain the reason, but you will be able to on the right. So before we go, let's since we do the Anova, I think it's good to talk a little bit about the t-test. You can do t-test in Excel. Okay, so let me copy this. Can you see my Excel spreadsheet? Can you? Oh yeah, it's good. So let me copy this data and I put it right here. Okay. Suppose I forget new territory, just focus on Hong Kong and Kowloon, the data we have. Okay. And then we want to do a t-test. Okay. Actually, we covered last class already, right? I want to see if the Hong Kong and Kowloon are different, say. Okay. And in that case, you go to data and again, data analysis. Okay. And then you do a t-test. Okay. So you go to data analysis, you go to the end. There will be several of them. There will be t-tests, assuming equal variance, assuming unequal variance, paired. Okay, let's look at the first one, assuming equal variance. Okay, so what you do is you do the input again the same. Okay, and you put variable 1, it's Hong Kong. Okay, column A, variable 2, it's Kowloon, variable B here. Okay. And what's different between them? The mean is 0, okay, as standard. The label in the first row, we do the 5%. Okay. So you put it here, choose the output range. Is that okay? Any question up to now here? Okay. If there's no, then we can go okay. So you will see here the first 3 rows are the summary of the data, right? So that is the blue region, okay? And this is pull the variance. This is something that actually you learn it Hope you still remember this guy, right? Just maybe I just explain what it's about first, right? This is x bar 1, right? This is x bar 2. This is s1 squared. This is s2 squared. This is n1. This is n2, right? And this is sp squared. So what's sp squared? If you still remember, there will be n1 minus 1, n1 plus n2 minus 2, s1 squared plus n2 minus 1, n1 plus n2 minus 2, s2 squared. Just pull the variance. This is saying h now is mu1 is equal to mu2, okay? And degree of freedom is 7, which is coming from n1 plus n2 minus 2, okay? 5 plus 4 minus 2, right? The t statistics is what? This t is x bar 1 minus x bar 2 divided by pooled over n1 plus, right? So that is the t statistics. And use the two-tail maybe, right? The two-tail, this is the p-value. So this is less than 5%, then reject the null that they are the same. Is that okay? Any question? I hope you can see what I have done. So this is a equivariance, and you can do the same for the unequal variance. Actually, the same thing. Say, suppose you do it again. Instead of using the equal, you also unequal. Okay. And in that case, you would just highlight the variables, okay, as we have done. Okay. And then 0 mean that everything same. The output will be somewhere here, maybe. Okay. So let me clear it. Okay. Maybe I just put it up there, more conveniently located. So you can see the same. We have the above is again the same thing, right? Because the summary is independent of the test, right? But we don't have pool variance because the variance will be right, because the t-stat coming from the following, right? The t-stat. How to come to t-stat, right? This will be x bar 1 or x2 bar, right? Coming from s1 squared over n1 plus s2 squared over n1, right? And s1, s2 is here, right? And you look at this, you also reject. Actually, you can see there's not too much different, right? Degree of freedom is something complicated. We know it from the quiz and also from the slides. It's a very complicated object, right? Something like this, if you still recall. Something very complicated. Something like that, right? And then you have to calculate that, but Excel calculate for you, so you can just do the text focus on. Okay, so you can do the equivariance. Also, you can do the pair difference. Okay, the same thing here. Same logic, just to in case some of you want to know. The same here. You can see there's a pair the sample, but for this one, you need to make sure that the range are same, otherwise it doesn't work, right? So if in that case we have to, because this paired sample must be paired, so you have two observations, you do not have different sample size, okay? So you just do the same, it will give you the same result. Okay. Any question about the Excel? I hope that's clear. Is that okay? If there's no further question, then we go back to the Anova. Oh yeah, you just write down this. Just write down the. Yeah. So two-way Anova. So here, instead of, before we remember what the data we have Anova, just to recap, we have say maybe male and female, right? And maybe looking at how much they spend on, I don't know, maybe spend on clothing, for example, or cosmetics or whatever thing. So it's a business application, right? So it's a bunch of male and bunch of female, how much they spend on maybe lunch or whatever, spend on some category, okay? And now, instead of one way, just male and female, maybe we can ask several things, male and female, right? But also we look at the location they live, right? Okay. Maybe you look at male and female, and we also look at location like Hong Kong, Kowloon, and New Territory, right? So that would be the two-way Anova means. So let's see. Oh, people ask me whether you can use it for the exam. Yeah, you can. But you tell me what you use, right? Use according to data analytics, and this is the result and whatever. But yeah. So the same as all the exam, then you have to explain how you get the answer, right? So just because of this is an online one, so I need to, have to prove that you do it by yourself. So that is the idea. Okay. So there will variable x here. There will be two-level factor, right? And remember, we have a gender. Okay, and then we have location. Right. And then we have each observation, right? How much they spend depend on whether they're male or female, whether they're Hong Kong Island, Kowloon, or New Territory, right? So for each observation, you associate them with the grouping, first level grouping or second level grouping, okay? And there's C number of level one grouping and the R of another grouping, okay? In this case, C is 2 because we have male and female. For this case, R is 3 because location, the 3 location, okay? So here we now impose an important restriction, okay? And this restriction is needed because of the derivation of the formula here. This is not absolute necessary. You can relax that for advanced purpose. So for our class, let's focus on the case where each combination, say male, Hong Kong, we have M prime observation, say M prime is 8. So we have 8 men from Hong Kong, 8 men from Kowloon, 8 men from New Territory. 8 female from Hong Kong, 8 female from Kowloon, and 8 female from New Territories. Okay, so the total number of observation will be RC times n prime. So this is the simplification. Okay, so it need not be how can I say? It need not be as I said, it need not be the most important restriction, but just we have that. Okay. No further question, then we continue. So this is a rather complicated form, but what it said is just each observation can be written X, I, J, K. Okay. I is the grouping based on A, J is the grouping based on B, and K is the number of the observation order, number of observation, right? The K observation, okay, in that group, okay? And don't worry, we are not using this, we just use the notation. Again, that will be what we have in the view was this kind of data. Okay, so you will be this is a data that usually you see in Excel, okay? And actually we'll do it, show it to you. It's A1, A2, and A up to C, and this is first level of B, and this is a half level of B, okay? And because as we said, each combination of only have our n pi observation, so this is a very nice rectangle, okay? If this is longer than this, then things will become much complicated, okay? But we focus on very simple case because you will later you will see this is already rather complicated. Okay, is it any question about the data? Because if you don't understand data, then it's no hope to continue. Is that okay? Good. So if there's no question, then we continue to the next one. So again, there's no different. The idea is again is X, I, J, K. Each observation follow a normal distribution classical model with mean mu ij, which is a constant, and with a sigma square. So that is the assumption. Or you can write this, you can decompose it the constant part and the variable part, right? And then this ijk, the error term, will have a normal distribution with mean 0, sigma square. Okay. So you like this one or you like this one, also fine. So regardless of which you like, okay, this is also fine. Either you like each representation. Okay. And the next part will be, we have this guy, which is here. Okay. We can decompose it into the following 4 elements here. Okay. So remember, I is either male or female. J here is with Hong Kong, Kowloon, and New Territories, right? So the mean of each observation, each group, whether male, female, location, right, can be composed of the impact of overall the whole Hong Kong, okay? And you'll be affected by whether you are male or female, right? If you're male, then it's an impact of male or female, right? And coming from here, right? It's not surprising because it's same as last one, right? There's some impact, the treatment effect due to you are in the male or female, okay? The next one is whether your locational impact, right? Whether you are located in Hong Kong or Kowloon, New Territory will affect you, okay? The third one is a little bit more tricky, okay? This is something new, is interaction, okay? It's where maybe Hong Kong and male gender or the location doesn't really affect you, but might be actually is you are located in Hong Kong and you are male, then you'll be affected, right? Or if you are female in new territory, then you're affected. Okay, so that is a specific thing. So it's a interaction affected. Okay, it's by itself may not have any impact, but both together may have together impact. Okay, for example, looking at the consumption in say clothing. Okay, and you know that the new territory usually is more open space, it's more cooler, right? So you can imagine that the winter clothing spending may be more for women in the new territory. Okay, the reason is being that maybe it's more windy, right? And then you need to spend more on the coats, say, for example, right? And the women clothing tend to be more expensive. So that would be the spending would be more. Okay, for example, like this. Is that clear what it is? So for the rest, this is the model. For the rest will be rather simple. Okay, so just mechanical, and we don't explain a lot because everything follow, and the proof will be similar, but we don't prove it. So the idea is asking the following three questions: is treatment effect from A the same, or from B is the same, or is it the combination of them has anything? Okay. So whether in this case, whether male or female will make a difference. It's whether where you live make a difference, right? It's Hong Kong, Kowloon, and New Territory make a difference, right? Here is it Hong Kong male the same as Hong Kong female, or is it Hong Kong? Sorry, is it Kowloon male, Kowloon female, New Territory male, and New Territory female? Are all these six things they're different or same? Okay. Is that clear what we are doing? And for the rest, we will figure out that it's very easy because it will be we just mechanically formulas, and you apply to Excel, so you don't need to worry because of. Okay, but just let's try to understand what they are. Okay, just at least in quickly in principle. Okay, so here is grand mean. I don't think they will be complicated because it's adding all observation and thereby n, right? So to understand this, it's best to I can look at data. Okay, so let's look at the data again. Okay, we have A1 and A2. Let's see the color. B1 and B2. Okay. And we have for H1 observation 1, 1, right? 1, 1, 1, and 1, 1, 2, and up to 1, 1, n prime. Okay. Same for the rest. I'm not going to write it down. For this one, you just all the cells you average up, right? And maybe I should go down a little bit. And at the end, you have B of R. Okay. And what here you can see here is this is a color. So ith level of A, okay, just fixing a level, say 1. You look at what it said is look at the column sum. So this is no different from what we see here. Okay, This actually this one. So what it means is look at the column I, okay? You just sum all of these up. So the column I, you summing from B factors from J from 1 up to R. So just go sum everything up for each group B and for each observation from 1 up to M prime. Okay. Do this and add them all. So basically adding all the whole column. And how many observations you have in total for each one of M prime. So R of them, R times M prime. So that's the formula here. Okay. Another one you will see is the Jth level B. You can imagine it will be just this, right? Just all the row we have to be add up and average, right? So basically it's just dot J dot bar. So just similarly, you just add up all the columns. For each column and row, we just add up everything there. And the C of them, the C times M prime. So that is what it means for the green. Just add up all these columns. Okay. I hope that is clear. So now here is again the same thing, but it just focus on particular factor. So it's like this. A1 and this is B1. There's A11, A11, also A111, A112 up to A11N prime. So for this one, you just average this particular number. Okay, add them all up divided by total number of them is M prime. So it's just particular combination of factor A and B and just average everything there. Okay, just notation. Okay, but don't worry, you don't need to calculate, but just you need to know what are these. Okay, so here is again very mechanical. You just need to know what is it about. So this is just SST, just same as what we expect for each observation minus the overall mean. This is grand mean. Okay, and what you're doing is you go for factor A, everything there, factor B, everything there, each observation. So that is overall. Okay, SSA. Okay, SSA is saying that, okay, we place everything A by its group mean. So basically it's just like this, right? Just recall, this is A1, this is B1, B2 here. Each observation, you don't use the offset, it must be X11, right? And X11 N prime. So all this thing, okay, replaced by column average X1 dot dot, okay? Because column average is this one, you replace this by this, okay? So basically looking at the average between groups, right? Same as SSG, right? And similarly, we have factor B here. You replace, if you do this, you replace every observation by its the group's mean. So it's called SSB. Okay, so basically the same, but you replace observations from the mean, the group mean. Okay, you can see the in front the same, just adding all the observation. Okay, I hope that is okay. There's nothing because it's definition. So whether you know it or not, there's nothing to understand. This you need to understand the notation. So there's nothing but just definition. Here we define SSAB. Okay, we'll try to give intuition later. But what it is you put the group that the particular factor ij and dog, okay, which is the average in this cell, minus the group of I mean and j mean and plus this one, okay? So we'll try to explain what it is, but this is the interaction, okay? And finally, we have random variation, which is each data minus the mean within the group. So it's inside this particular factor, what are they? Okay. And turn out this very funny thing is the first one can be decomposed into the following four, which we don't prove it. It's beyond the scope to prove that. Although you may be able to do it, but we just don't want to spend time on this one. So I guess the important is how to use it, right? So let's give you an idea why this is the case. Okay, so this overall mean is trying to not equal, but I think it's trying to estimate this mu. Okay, if you look at this, it's trying to estimate this guy, and this is trying to look at what should be this guy is, right? Because you average all out, other things will be gone. You average this out, you just remove all the random term here, okay? So that's why this is used in the SST, right? This is used in the SSA. This is used in the SSB, okay? Now the reason I want to explain is why with SSAB, right, is xij dot, which is this guy, minus xi dot dot, which is SSA, right, and minus SSAB, okay, minus x bar dot j dot plus x bar. You look at this, you look at this one, minus this one, minus this one, plus this one, what you left is looking at the tau ij, okay? So that's why later we see the interaction effect, we'll use SSAB. Look at the impact of, say, A, the male or female. Look at this one. Look at the district. SSB, look at the SSB, look at this one, okay? This is SST, okay? But we don't go further. There will be some idea, but this is not the proof. Again, just some explanation, okay? Again, I don't provide why you divide C minus 1, you divide I also minus 1, and why AB is dividing this. This is, you can imagine this formula. To do it carefully, you need the proof. So we are not going to provide the proof, but instead we just provide the formula and just to provide you the idea. So remember, we have C groups, okay? We want to see whether the group are the same. So the formula will be the MSA over MSE, okay? So we are not going to explain why this is the case. Again, this F test, you will be rejecting on the right. So basically you put, it's a one-tail test. Okay, you put all the, see the critical value, basically just you do this, right? You just kind of compare. If this one, you calculate this guy, F here, right? You calculate this guy. Is this bigger than P or less, sorry, bigger than alpha or less than alpha? Okay, but of course, don't worry, this will be automatically given by the Excel. So we just need to check the p-value directly. Okay. Any question? If there's no question, then we will go to the B. Will be the same. You just replace everything C by R, R by C, A by B, then it goes same. So I guess the important is this interaction. That would be look at the interaction and the same thing here, but you look at the SSAB, the same thing. Okay, you just replace when you have AB, then you would replace by AB and everything will be the same. You again look at the end tail, the right tail, and then you decide whether reject or not. But again, the p-value is given by you, by Excel, so you don't need to worry too much about those. Okay. So any question? Of course, I will show Excel how we do it. But before you did, is it okay? Because this is a little bit there's nothing to explain because it's kind of formula applying for these things. Okay, if there's no question, then we are going to show the Excel, I guess. So let's, can you see my Excel spreadsheet? So let's look at data. We have, maybe we have male or female, right? We have Hong Kong, okay? Maybe we have free data, Kowloon, okay? And new territories, okay? And maybe we have data like, doesn't really matter, we just put arbitrary number here because we just try to illustrate maybe I don't know what this number is, but let's consider they are, I don't know, whatever number, okay? Okay, maybe we have this current number data, okay? And so you can see this is Kowloon data, Hong Kong data, and new territory data, and male and female. So this is the data we have, okay? So for each combination male and Hong Kong, we have 3 observation, male and female, Hong Kong and female 3 observation, Kowloon and male 3, and they have combination of 3 observation. This is data, okay? You can use your own input. Don't have to use me, don't use my one, but I just try to show you, okay? So what we are going to do is again, go to data. So go to data and data analysis. Okay. And this time we will use Anova. We will use Anova 2-factor with replication. So basically the second one. So the first one is to input the data range. I guess that should not be an issue. We just click the whole thing out. Automatically, you expect to write the label here. And how many rows per sample? Basically, is M prime. So this is asking M prime. So M prime is 3 because we have 3 number of, for each combination, we have 3. Okay. Alpha, we put 0.05 is standard. Is that okay up to now? If there's no question, I just put the output there and I click OK. So here we have the two sample replication, the data here. Okay, so the first is summary. You can see the summary for Hong Kong, male, female, Kowloon, male, female, literary female, total. So basically just have everything there. Okay, so of course the important part is here, which is the key we want to look at. Okay, let's yellow out this area. Okay, we just comment on what are these. Okay, in this case, the sample in this case is the B, the columns are A, right? The interaction are A, B. Okay, within is E. Okay, so this is SSB. This is SSA. This is SSAB. This is SSE, and this is SST, and this DF representing those. So this is MSB. Okay, and this is MSA, and this is MSAB. Okay, and this is MSE. Okay, and this F, right, will be just MSB over MSE. Okay, same for this one, it will be MSA over MSE, and this will be MSAB over MSE. Okay, and you can calculate p-value. Or critical p-value is again, look at F, look at the right tail, and the degree of freedom is given by here. Okay, and then you can check. Now we are going to check whether the data tells us. Data tell us you cannot reject their sample. So the sample, the B column, just B is Hong Kong, Kowloon, and Hong Kong. Actually, there's no difference between the area, but the column is less than 5%, means whether the gender will make a difference, whether we're male or female to make a difference. Interaction is also less than 5%. So that means that whether you are male and female together with the location would make a difference. Okay, so that is what it's about for the Excel to calculation. Is there any question? Any question? If no, we just left 1 minute. Maybe I don't know we have time, but just I guess 1 minute we can still talk about what it is. So the next or the last topic in our regression, just remember we finished the Anova, but we don't have quiz next week. So next class we'll wait until the last one. So linear regression. So the answer is very simple. I just very brief, and then we will talk about this more next class. So basically, what you have is you have a bunch of data point, two-dimensional data point, a variable x and y, and the data point represented by x1, y1, xn, yn. So variable usually you care maybe paired is like whether they have y is income and x maybe education. Okay, whether education affect income or other way around, or you care about maybe X is they spend maybe your Amazon or the e-platform, X maybe the money they spend on good, maybe spend on food. Is it related to they spend on other computer, whatever? Okay, so we're just trying to see X and Y. And you are trying to find a best line to fit it. So basically just one more graph, I'm done. Okay, so basically what this whole chapter is about is the green are the data point. You're trying to figure out what is the line to best fit this. By best fit here means there are many explanations, but what particularly we use is the vertical difference, sum of the vertical difference, square of the difference. This difference is small, okay? So if you have some like this, then it's not good because distance is very large. And this is even worse, okay? So that is to find the best fit line in a two-dimensional scatter plot, okay? So the rest of this class is about, okay? So I should end here. Let me know if you have any question. So have a nice day. The quiz will be there once we finish the regression. So there will be only one final. We combine the two quiz together. Yeah, same as homework, we'll combine together. Yeah.
Professor 想問下，咁你之前話你要 post 啲 details of project 喺 Babel 度啦，但係你 Babel 嗰個 project 嗰個 deadline 係4號咯。
12月4號，12月4號。
哦，12月4號就係 project deadline。
即係最後一個學期啫嘛。
Yes，係。但係你打咗11月4號。
哦，我打錯咗，但係 homework 嗰度寫12月4號嘅，唔好意思啊，我而家改咗，我未改啊。
咁我想 make sure 下，因為你而家 combine 咗啲 quiz 啦，即係你可能2個 topic 就1個 quiz 啦。咁但係你之前計quiz 嘅分係 best 8啫嘛，因為你話有
participation， 即係你參加咗有分㗎啦。
哦 ，sorry， 聽唔到。
你參加咗有分㗎啦。
哦，好啊，唔該晒。
Professor， 我想問交功課嗰度咧，係咪交完之後就可以有個review 翻，即係我 send 個檔案嘅？即係
我唔知你講乜，即係咩意思？唔好。即
係我當我 hang 咗assignment 3啦，跟住交完之後咧，佢有個畫面咧可以睇翻我交嗰份文件係點嘅，即係入邊。應
該係啩，我冇用過喎，真係。如果你你可以問下 TA， 因為我冇管功課嗰嚿嘢。
但係淨係想問咁你如果你改咧係會 down 落嚟改，定係淨係睇個版面
？TA 會改，應該會改完話俾你聽點咯，我諗係。我唔係好清楚佢點改，因為 TA 改嘅呢個係。
即係呢個應該問翻 TA。
問翻 TA， 我唔知佢點改，佢可能打出嚟又得，或者我唔知佢點改，因為佢就係睇個答案啱唔啱，睇下你有冇計啱啊嘛，咁樣咯。
因為我見佢即係好 minor 嗰啲咩括弧嗰啲嘢，佢變咗錯碼咯，即係淨係括弧嗰啲咯，所以我驚有影響嘅。
應該冇嘅，有問題你問翻個 TA 咯，我諗係呢個。
好，
因為唔係我改，所以我唔係好清楚呢個。
好，唔該晒。
OK。